2 deals with radioactive decay. It says that the half-life is 20 days, and it says that we're starting with 50 grams of kryptonite, and it says it's an example of continuous compounding. So I know that I can use that fancy equation P e to the RT to model this decay of kryptonite. And it doesn't look like it tells me what to call it, so I'll call it K of T for kryptonite. It tells me that I start with 50 grams, so I can now rewrite this as 50 times e to the, and then I don't have a rate. I don't have a rate. But I know that it says the half-life is 20 days. So I guess that means I'm going to have to solve for the rate. If I plug 20 in here, that would be like as if I was solving using the information of the half-life. And again, a half-life means that I'm going to eventually have half of the original amount. The original amount is 50, so I'll write 25 here. Now I know that I need to divide both sides by 50, and of course that'll give me that 1/2 is equal to e to the 20r. And I look at this for a moment longer and I remember, okay, to get rid of this e, I can take the natural log, but if I do it to that side, I also need to do it to this side. So using the power rule, I now have 20r ln e equals ln of 1/2. And I know that ln and e become 1, so I can just cross that off. To solve for r now, I divide both sides by 20, and I get that my rate is actually equal to ln of 1/2 over 20. That whole thing is my rate. So now when I look at problem A, it says, how much kryptonite do I expect to have after 20 days? Well, it told me that I would have 25 days, or 25 grams, because that's the half-life. After 40 days, well, I'd have 1/4. After 60 days, I'd have 1/8. And after 80 days, I'd have 1/16, just by definition of half-life. Every 20 days, I'll have half of the next amount. So K of 20 should be 25 grams. That's half of 50. K of 40 should be 12.5. K of 60 should be 6.25. And K of 80, again, is half of that, which is 3.125. Of course, it's kryptonite and it's in grams, so I need to include my units in each piece. I actually already began doing the work for B, creating the exponential equation. I've got almost all of my pieces right here. I had 50e to the r, and now I can replace that r with the rate. So the kryptonite at time t in days is equal to, let's see, 50, that's how much we started with, e, because that's an example of continuous compounding, and then the rate we found was this thing up here. So I'm literally going to write that in there, ln of 1/2 over 20 times t. That whole thing is an exponent. And that's part B. To find part C, how long will it take 90% of the kryptonite to decay? That would be like saying 0.90 times 50, that was the original amount, equals 50 times e to all this stuff again. I'm going to need to divide both sides by 50, which of course leaves me with 0.90 equals e to the ln of 1/2 over 20 times t. Again, to solve this, I've got to take the natural log of both sides. And I see right away that I have ln of 0.9 equals, that stuff goes away, and this becomes ln of 1/2 over 20 times t. Divide both sides by ln of 1/2 over 20. Remember, that's the rate. Make sure that I have this right. ln of 1/2 over 20. That stuff cancels out. And then over here I get t equals, and it would be natural log of 0.9 over natural log of 1/2 divided by 20, which, using properties of reciprocals or keep, change, flip, means that I've got to go ln of 0.9 times 20 over ln of 1/2. I know, it's weird. Get over it. And so I end up with 20 times natural log of 0.9 over natural log of 1/2. And that is my solution. Now notice that I was solving for t. It said how long. That's a when. And the when would represent the time in days. So that answer would be in days. And as always, we would round it to 3 decimal places once you've calculated that.